Right. So basically, these are the things that we were talking about last week, right? We get to know like there are two types of gates, logic gates, which we call basic gates, and the on the other hand, it is the combinational gates. So basic gates basically divide into three parts, which is not and O, and we talk about what are the operations of those and how we can illustrate those operations using a truth table. And we learn about the truth table, and we get to know that inside a truth table, one is indicate the true, the value true, and 0 is indicate the value false. All right. And for these three basic gates has their own operations. So NOT gate will indicate you an inversion, and AND will indicate you a multiplication, and O will indicate you an addition. But all these things are not in general mathematical manner, but in the Boolean manner, or like in related to the Boolean algebra, these operations are being taught, right? Right. Okay. And people, today we are going to learn about the combinational gates, right? So in our diagram, we just had it into two parts, which is called the basic gate and the combinational gates, right? And today we are going to learn about the combinational gates. All right. So I may draw the combinational gates, and you can start drawing. No, first of all, just see what I'm going through, and I'll explain the things. Then you can draw the things, right? So I'm going to use the same hierarchy at the beginning because we are talking about the gates again, right? So we know like logic gates, they divide into two parts, which we call basic gates and the combinational gates. Right. So today we are going to learn about the combinational gates. Now, combinational gates are divided into two parts. Actually, like not actually the two categories. Actually, there are three categories, but onto our syllabus, we just talked about only two things, or like the two kinds of gates. So these two gates are given the name as NAND and as NO, right? So you can see that AND and O word is there, like in front of the AND and O word, there is a letter N are being concatenated, right? So combinational gates, when we are designing the combinational gates, the concept that they are using is they use these basic gates to create the combinational gates. So what they are doing is basically they take the AND gate and they are going to fix a NOT gate in front of the output of an AND gate, right? So AND gate output, we know it's A dot B, and to that output, they are going to fix a NOT gate. So that output A dot B is going to travel through the NOT gate. AND gate එකේ output එක ඊට පස්සේ NOT gate එකක් ඇතුලෙන් යවනවා. එතකොට AND gate එකයි NOT gate එකයි combine කරලා තමයි NAND gate එක හදලා තියෙන්නේ. So that is why excuse me. That is why it is called the NAND gate. So if I illustrate what actually happens, this is what actually happens there, right? So this is the way the AND gate stays, and to the output of it, let me have a lengthier output so I can write the function. And in front of it, they are going to fix a NOT gate. So what will happen when A and B are being input? A dot B is going to be the output over here. Excuse me. When it is moved through a NOT gate, it's going to be A dot B. It's better you put the brackets when two or more variables are there together. And once A dot B moves through the NOT gate, A dot B is going to take a bar over it. Or you can write this as A dot B dash. Right? So this is what is actually happening. But if you are asked to draw an AND gate, this is not the circuit that you are going to draw. It has a one single circuit, right? So that circuit can be drawn like this. So it has two inputs, basically, an AND gate and this circle from the NOT gate. So this is what you call NAND gate, right? So here, the operation shows like this. Once A and B is given, A dot B total bar O A dot B dash is given as the output. And if you are thinking about, if we need to illustrate its operation using the truth table, this is the truth table that we are going to use. So basically we have A and B as the inputs and A dot B bar as the output. And now we know from the previous week what could be the combinations for this A and B, right? So when A is 0, B can be a 0. When A is 0, B can be a 1. When A is 1, B can be a 0. And when A is 1, B can also be a 1. Right? So when you are writing the output, it's better you be careful because it has a multiplication as well as an inversion. So first you do the multiplication, then you invert. So 0 into 0 gives you 0. Once the 0 is inverted, it is going to give you 1. Yes, Davidu, the black color, the gate that you can see is the symbol of the NAND gate, right? Here at the above, I was just explaining you what's actually happening. If you are asked to draw the NAND gate, it is this symbol that you need to draw, right? Okay. So 0 into 0 is 0. Once it is inverted, it gives you 1. 0 into 1, again it is 0. Once it is inverted, it's going to give you a 1. 1 into 0, again it's a 0. Once it is inverted, it's going to give you a 1. 1 into 1 is 1. Once it is inverted, it's going to give you a 0. Right? So this is going to be the truth table for the NAND gate. Is that clear, everyone? Can I have the confirmation? Okay. Right, okay. Dihan, you raised a hand. Yeah, Dihan, what should I need to repeat? And Gavindu, inversion means the operation that happens when something goes through the NOT gate. Previous day, we talked about it. once A is gone through a NOT gate, the A bar is given. Dihan, yes, I'll show you how to settle the truth table. So, Dihan, can you understand once A and B is multiplied, like on the operation of A dot B, what is happening is the values of A and B is being multiplied. Can you understand that, Puta? Yeah. And Dihan, here, like other than the multiplication, there is an inversion which indicates from this bar. That means, Dihan, you have to multiply first, then you have to invert. So whatever the answer that you are getting from the multiplication will be inverted. That means if it is a 1, it's going to become a 0. If it is a 0, it's going to become a 1. Dihan, again, inversion, we talked about it last week. It is what is happening when something moves through a NOT gate. So once A is being flows through a NOT gate, A bar is being created. Right, we talk about it with the truth table as well. So here the 0 is given to A, so it will become 1. 1 is given to A, it will become a 0. Dihan, is that clear? Yes, yes, Dihan. You can take it like that, multiply and make it as its opposite. But according to the Boolean algebra, we have to use the terms called in inversion and Boolean multiplication. Simple as that. Clear? Right, great. Something very similar is happening with the NOR gate as well. Right? So how the NOR gate, the concept behind the NOR gate is, they have this OR gate and its output is directed to a NOT gate. Right? Let me draw it a bit lengthier so I can write the equation without a problem. So here, what's actually happening, if A and B is given as the input, this is going to produce you A plus B. And once it is moved through a NOT gate, it's going to produce you A plus B and a total bar. Or else you can say it is going to be A plus B within brackets, and outside the bracket, a dash. Right? And in the very same way that we represent the NOR gate, we represent the NAND gate in a one single gate. Here for the NOR gate, we have another one particular symbol which use the same concept and can be illustrated like this. So A and B is given A plus B. Total bar will be produced. O A plus B dash will be produced. Right? Yeah, Dihan, we discussed about this last week. Logic gates is the basic component of the integrated circuits, ICs, right? Which you can see on the motherboard, right? We are going to discuss about those during the lesson, right? So you have to have patience until that point comes, right? You'll get to know. Right, and here how the truth table is going to happen In the same way, you are going to have A, B, and A plus B. Total bar is going to indicate the output. So the combinations are going to be same, 0, 0, 0, 1, 1, 0, and 1, 1. And A plus B total bar, A plus B total bar is going to give you the thing, what you are going to do there is like add those things up and invert it, right? So that means 0 plus 0 is going to give you a 0. Once you invert it, it's going to become 1. 0 plus 1 is going to give you a 1. Once it is inverted, it's going to give you a 0. 1 plus 0 is going to give you a 1. Once it is inverted, it's going to give you a 0. 1 plus 1, according to the Boolean algebra, we know the answer is 1, not 2. And once it is inverted, again, it's going to give you a 0. So that's going to give you the truth table of the NO gate. Yeah, people, any questions? රිසර බූලියන් කියන එකට තියෙන සිංහල මීනින් එක පුතා අපි බූලියානු කියලා කියන්නේ දැන් කියන්නේ අපි අර බීජ ගණිතය කියන දෙයක් කියනවනේ ඒ වගේ දිහාන් yeah, what is the place that you are not understanding, Buddha? Is it the truth table again? Yeah, Dihan, you have to concentrate on the operation, what happens here. So this operation says add it up, then invert, right? Yeah, others, you can start writing, right? So Dihan, it's in your words, it's like add up and making it into its opposite. First, you add the A and B, then you flip it or making the opposite of it. Can you take it on that meaning, or like where we use inversion for that? Right, Gihan? Right, okay. All right. Yeah, someone is done already, right? So others, do it as quickly as possible. Right, let me know when you are done. All right, people, let me know once you are done. All right, one is done. How about others? Actually, not one, like 2 or 3 we have done. How about others? Okay, Gavindu, keep it up and hurry up. Okay, how's the situation, people? Are we done? Okay, okay, hurry up, hurry up. Okay. People, is there anyone still writing this? Okay, okay, keep writing. Okay, people, how's the situation? Anyone who is still writing? Okay, hurry up. All right, people, how about the situation? Right. So let's move forward. Now, once we get to know about these things, like get to know about the gates, if we are provided with a particular circuit, we shall be able to draw it. Or like, I'm sorry, if you are given a particular circuit, we shall be able to derive the output using this knowledge, right? So what's the knowledge you want? It's about the gates and its operations. Later, you will realize you need the knowledge of the truth tables of a particular gates and to figure out how these things are working, right? First, we are trying to derive the expression or derive the final output from a given circuit, right? So that is what we are going to do now. So let's have that heading. So you can have that heading like this. Derive the output from a given logic circuit. Right, people, just a minute, just give me a minute. I'll be right back. All right, now, as an example, just look at this circuit which is provided to you, right? So there is a input A which goes through a NOT gate, and there is B which flows like this with an AND gate, and the output of it is going to combine with the C and flows through an OR gate. So if I assume the output as Q over here, no, Gavindu, we haven't tried anything yet. I'm just explaining, right? So if you are given this kind of a circuit, and you will be asked to take the output, or like you are asked to take the representation of Q using A, B, and C, right? So this is the way that you are going to do that. This is very easy. When A is provided over here, so A will be an input to this NOT gate. So it's going to produce you A bar, or else you can represent this as A dash as well, right? When B is providing, so B will be first meet this AND gate. So now you can see A bar comes from 1 as a 1 input, and B is coming as another input to the AND gate. So the output is going to be A bar dot B, and it's better you have brackets when there are 2 or more inputs to a particular gate, right? When we are writing the output. And then A bar dot B is going to be an input to this particular OR gate in one line, right? And on the other line, it's going to be C. So that means Q is going to give you, right? Or like the output is going to give you A bar dot B plus C as your output. So you can bracket this, or else you can write it without the brackets, right? And in case if you use the dash instead of bar, it's going to be A dash dot B plus C, which is going to be the output. Is this clear, people? Yes, everyone? Is it clear? Right, great. Okay, so copy it down, and I'm going to give you a small question regarding this. So you have to find the output of that particular gate, of that particular circuit. And then after we can move to the, there are some questions in the textbook. So we'll try those things out. Then we'll go for the next topic, right? So copy it out. Right, and I'll write the question over here. Derive, it's the derive, D-E-R-I-V-E, derive. I'm sorry, it's not very much clear. It's better we see, I'm sorry people, it's better we say deriving, not just derive. I may write it. Deriving. And when you are done with this, done with the writing of the example, you can try taking the output of this circuit, right? Right, you can type me the answer. Okay, some are sending the answers. Yes, method. Yeah, your answer is correct. It's better you indicate the operator in between brackets method, right? Brackets දෙක අතර මැද්දේ indicate එක. And Risara, another Risara, Dihan, are you clear with the topic? Is that okay? Rusiru, yes, your answer is correct. And Yadisha, yeah, Pudad, the operator that you have used in between the brackets is not correct, Pudad. Just see it through. Dilni, yeah, your answer is correct, Dua. Rannima, yes, yes, that is correct as well. Very good, people. So everyone who has done it, so good. Okay. So let me illustrate this to you. Just see whether, do you need any time? Is there anyone who needs any time to figure this out? If you are still doing it, I can give you some time to do it by your own. Okay. All right. Then let's talk it through. All right. Okay. Okay, Davidu. Okay, Ranuja, you keep doing. And Binadi, yes, Binadi, yes, yes. You may type the correct one. Right, and for the people who have done this, you people can, yeah, Risara, yeah, that's correct. That's correct. Binadi, yes, Dua, that's correct. So people who have done it, you can try the questions in page number, what's the page number? Yeah, this. In page number 122. Right? Oh, hold on. Not that. Yeah, in page number 121, the A, B, and C parts. Right? So they're asking you to construct the truth table as well. But for the moment, you don't know how to do that. Just take the output of these circuits for A, B, and C. Yeah, Gavindu, Puta, there are some mistakes. Litira, yes, your answer is correct. Yeah, okay. Let me illustrate this to you, how the output is going to have. No, you don't need to draw the circuits. Just take the output, that's all. If you can do it on your textbook, do it by using a pencil, right? And just take the output. Rusira, no, you don't need to copy. Book එකේ තියලම කරන්න, right? Ranuja, still you have some mistakes, Buddha. Let me do this. Let me do this and show you people how the things are going to happen. Dihan ලියන්න ඕනේ නැහැ. Circuit එකට අදාළව උත්තරේ විතරක් අරගන්න. Right now, how we are going to solve this? You are going to receive A over here. So you are going to have A bar over here. And you are going to receive B over here. So that means NOT gate will give you a B bar, which is going to be an input to the AND gate. So this AND gate will give you an output like this, A bar dot B bar. And some of you have written this. Some of you think this A bar dot B bar is equals to A dot B total bar, which is not. This is wrong. These two are not equal to each other, right? These two illustrates two different things. This is A being inverted and B being inverted, then multiplied, right? Here the case is different. This is A and B are being multiplied, then inverted. So two different cases, right? So these are not equal. So if you find this, don't convert it like this. May then මෙහෙම දැක්කොත් මේ විදිහට ලියන්න යන්න එපා. ඒක වැරදි. Right? A bar dot B bar නම් තියෙන්නේ. It is A bar dot B bar, nothing else. Right? Then if you think about this O gate, here you are going to receive B. ඇයි ඒ මෙතනින් B මෙයා B වලටම connect වෙලා ඉන්නේ. Then here in C, C is going to receive over here. So it is an O gate. So it's going to give you B plus C. Right? And then it's going to be the inputs for this AND gate. Right? So AND gate is going to multiply whatever the things that they are receiving. Right? So how we are going to illustrate this? One thing that you are receiving is A bar dot B bar. And in the other hand, you are going to receive B plus C. And in between the brackets, it's going to be a dot. Right? Or either you can write this using the dashes, which is called the A dash dot B dash dot B plus C, like this. People, is that clear? Yeah, Litira, now you can, Litira, is this the answer for the textbook thing? Okay, people, I'm going to do the textbook circuits with you. So just write it and keep the answers for yourself and see whether it is correct. Any questions regarding this? May question you can ask it now, and I'm going to do these circuits by another 5 minutes. So it's 6:37. I'm going to do it by 6:42. Right? So give your best shot, right? And do it very slowly. Take it into your mind and do it very slowly. There are different kinds of gates. So just take the operation, right? Think about the operation, what is happening, and apply it. So I'm going to do it by 5 minutes, just after 5 minutes. So you can do it and see whether it is going to do it in a correct manner, right? And meanwhile, if you got any questions regarding this answer, you can ask. Yeah, I'm getting some answers for the textbook questions. So people, yeah, wait for a few more minutes. I'm going to discuss all three things, right? ලිතිර අහන්නේ මේ පළවෙනි එකේ මේ උඩින් පැනලා ගිහිල්ලා තියෙන වගේ කියලා නේද? ඒ ලයින් එක NAND gate එකට යනකොට. right? ඕක අපි පාවිච්චි කරන්නේ මේ කියන්නේ circuit අඳිනකොට අපි ඔක් කතා කරනවා. අපි කියනවා මේ circuits cross කරන්නේ නැහැ කියලා. right? කියන්නේ නිකන් cross කරොත් short circuit වෙනවා කියලා අපි කියනවා. ඒක නිසා අපි එක ලයින් එකක් උඩින් පැනලා යන්නේ. කියන්නේ ලයින් දෙක සම්බන්ධ නැහැ කියන එක ඉන්ඩිකේට් කරන්න තමයි අපි ඒක පාවිච්චි කරන්නේ. Right, people, I'm start doing the first one or the A part. Yes, Rusira. OR gate can take many inputs, like more than 2. Right? It's like the minimum inputs that an OR gate can take is 2, and the maximum it can go for more places, right? It can have two, 3, 4s and a lot of things. Right. So here comes the first one. So just check whether you got it correctly or not, right? So the in part A, so here it receives A, this receives B. So this is going to give you A plus B, right? And same A comes here, same B comes here, and this is a Nand gate. So what's happened to a Nand gate? It's better you have brackets for A and B. So in Nand gate, it multiplies and complements. So A dot B happens, then we'll have a total bar. And then these will be the inputs for this gate, right? So the Q is going to be then A plus B is there, that is a one input. A dot B total bar is there, that is another input. And in between these brackets, there should be a dot because this is an AND gate. You can write this using the dash as well, like this, A plus B dot A dot B dash. Right? So if you got any places to be corrected, please make that correct. And if you got any questions, it's time for you to ask. All right. So I'm moving to the second one. So in the second one, how it happens? Here it takes A and here it takes B. So as usual, this is going to be a NAND gate. So it will multiply, then inverted or complemented. And here the NOT gate is receiving B, since it is connected with the B, and it produced me a B bar. So one side it has A dot B total bar, and the other side it has B bar. So those will be the inputs to this particular NAND gate. And once it goes through the NAND gate, so one input that the NAND gate receives is A dot B total bar, and the other input is B bar. So NAND gate is capable of multiplying these two and applying a one big bar over it. Right? If you are writing this using the dash, it's going to be A dot B dash dot B dash. Then at the outside of that entire term, there will be a dash. Yeah. So do the corrections if you got any. And if you have any questions, you can ask. No problem. No problem, Dihan. Right. Gavindu, like, what do you mean? The main dash means the bigger one, the big one. What is like at the top of it? No. Definitely it's going to be an incorrect one, Gavindu. Because that big bar indicates the operation of the NAND gate, Nebuta. මේ දෙන්නනේ receive වෙන්නේ. These two are going to be the inputs. So those two should be multiplied. Then this, the big bar indicates the inversion or the complementing part. That is a must. If you don't have that, that means your answer is going to be an incorrect one. Right? Okay. Right. Here we go for the third one. So this is the third circuit. Oh, Dihan. Mama මේ snip tool එක තමයි පාවිච්චි කරන්නේ. මේ full screen snip කියලා තියෙන එක Windows 10 එක කියන්නේ snipping tool එකේම full screen snip එක එනවා මේ shortcut එකක් විදිහට desktop එකේ. ඒකෙන් එක සැරේ මට full screen snip එකක් ගන්න පුළුවන්. No, Ranuja, never. You can't cancel. There are situations that you can cancel like bar to bar. In that case, පුතා bar එකකට bar එකක් cancel කරනවා නම් those two bars should be identical. එකම size එකේ වෙන්න ඕනේ. එහෙම නැතුව අපිට bar එකට bar එකක් cancel කරන්න බෑ. Right? ඒ කියන්නේ ඔයාලට කොහේ හරි තිබ්බොත් මෙහෙම x කියලා double bar එකක්. ඒ කියන්නේ එකම size එකේ bars දෙකක්. Then you can write this as x. අර පොඩි bar එකට එකම જાතිය bars දෙක cancel වෙනවා. එක ළඟ තියෙන්නත් ඕනේ. එකම size වෙන්නත් ඕනේ. Otherwise you can't. Right? Okay. Dihan, I think that can be added from the taskbar options. Just search it and see. Right? කවුද මගේ ප්‍රශ්නය අහුවේ කවුද? Ravindu, is that clear? Ravindu ne dehuwe. Ranuja, is that clear? Right, okay. All right, moving to the third one. Yeah. Here what is happening is it receives A over here, it receives B over here. And this output is going to be A dot B. So it's a simple AND gate. And it is moving through a NOT gate. So it's going to give you A dot B total bar, right? Like it is going through an AND gate. And the other AND gate receives B from the B line and from C from here. Then you are going to receive B dot C as an output. So finally, you will be having another AND gate. Right? So the output is going to be A dot B bar comes from one side, B dot C comes from the other side. Then this AND gate will multiply these two. Right? Or else if you use the dash, it's going to be A dot B dash dot B dot C. Right? Dihan, in the exam, you will be receiving things like this. And there will be questions. අපි දැන් ඊළඟට ඉගෙන ගන්න හදන්නේ expression එක දීලා කොහොමද circuit එක අඳින්නේ කියලා. ඒ වගේ ඒවත් එනවා. Expression එක දීලා ඔයගලන්ට කියනවා අඳින්න කියලා. Sometimes they will give you the expression and ask you to construct a truth table. Expression එකටම truth table එකක් හදන්න කියනවා. ඊට පස්සේ අනිත් වර්ගය තමයි පොඩි scenario එකක් දෙනවා. scenario එකක් දීලා ඒ scenario එකට ගැලපෙන circuit එක design කරන්න කියලා කියනවා. ඔය જાති තුන තමයි exam එකට එන්නේ. Dilmi, though I'm not, මං හිතන්නේ දුව අහන්නේ bar එකයි dash එකයි දෙකම දාන්න පුළුවන්ද කියලා. Is that what you're asking, දුව? Yeah. No, it's like this. If you are using the bar, it should be the bar always to indicate the NOT gate. If it is going to be a dash, then use dash to every places that you need to use dash. Right? Don't mix those two up. Right? Will be a disadvantage for you. Dihan scenario means they will give you some එකන්නේ මොකක් හරි සිදුවීමක් දෙනවා පුතේ. කියන්නේ දැන් උදාහරණයක් විදිහට කාය එකක් තියෙනවා, කායක ඇලාම් එකක් තියෙනවා, ඇලාම් එක රින් වෙන්නේ මෙන්න මේ වෙලාවට මෙන්න මේ කන්ඩිෂන්ස් වලට කියලා ඒගොල්ලෝ කියනවා ඒකට අදාළව logic circuit එකක් අපිට හදලා දෙන්න කියලා. Right? අපි කරනවා. We are going to do those things. Right? So don't worry. When that point is there, you will get to know what it is. Right. Okay. Any questions regarding this? Okay. I think it's clear. So let's move to the next part. Right. So now you know what are the gates and what are the operations of those gates. And when a particular circuit is given, you know how to take the output. Now we are going to learn how to design a particular circuit once we are provided with the expression, the final expression, the MQ and F වලට අපිට හම්බෙච්ච expression එක දුන්නම how we are going to design this circuit, how we are going to draw it, right? What is the method, right? නිකම්ම අපිට එකපාරට අඳින්න පුළුවන්ද? Is there any rules for this, right? That is what we are going to learn. And we are going to draw these things using the basic gates, right? We are not there is no rule or there is no any limitations that you have to use basic gates to create a circuit, but there are methods that we use to create the circuits. Basic gates වලින් හදන circuits තියෙනවා, combinational gates විතරක් පාවිච්චි කරලා හදන gates තියෙනවා. ඒ දෙකවල එකතු කරලා හදනේවා තියෙනවා. In your syllabus, what they are asking you to draw is the circuits using only basic gates. That means NOT, AND, and O, right? Dihan, what you are saying quite hard means like the creating the gates or just deriving the expression. Right. So the topic is going to be designing. No, Dihan. I'll walk through. Right. Don't worry. It won't be a hard one. Right. There are no hard things in the ICT, and as well as people, there are nothing called hard in any subject. Only thing is you have to understand it, how we are going to do this. If you really don't understand how to do it, then anything is going to be a hard one, right? The simple example is, amma කුස්සිය උයේ ඉන්න ගමන් ඔයාට කිව්වොත් පරිප්පු එකට ලුණු දාන්න කියලා, that's going to be a very hard thing for you, even for me, right? Because I don't know how to do that. කොච්චරක් දාන්න ඕනේද නේද? හැන්දෙන් කොච්චරක්ද ගන්න? If you don't know that is why it is hard, right? So you just get to know how to do it, then it will be just a simple thing, right? Okay, so what we are going to do is like designing a logic circuit right? Designing a logic circuit using basic gates for a given expression. Right? So this is going to be your topic, right? So let's see how we are going to do this. I'll give you the time to write this down. Just follow me for the moment, right? So now as an example, I'm going to take this. I'm going to take this equation, like I'll take it like this. F equals A bar plus B dot C bar, right? And the question I'll write, draw a logic circuit using basic gates for above expression. Right. So once you are given that, no, Rusira, what you are asking cannot be done, Puta. මං අර කලින් අර තව දුවෙක් අහුවා ඒ ප්‍රශ්නෙම. පුතා bar එක පාවිච්චි කරනවා නම් you are going to use the bar in every place. If you use dash, it's going to be the dash in every places, right? Don't mix those things up, right? Okay, now once you are given this kind of a thing, this kind of a question, right? So the first thing that you have to do is, now people remember, now why I'm writing these steps, it is just to make things clear for you, right? You don't need to write these steps and do all these things when you are drawing the circuit. You just draw the circuit, right? That's all, right? I'm giving this is the first step, this is the second step, and this is the third step likewise. It is because for you to understand it clearly. That's all, right? You don't need to like follow up all these things. Like you can do it at once, right? So the first thing that you are going to do is determine the number of different variables in the expression, right? So Dihani, it's I'll write example in that manner. That is the example, right? So determine the number of different variables in the expression. What does this mean is you need to recognize what are the different letters that you can find on your expression, right? Variables. So how many different variables are there? There are 3 different variables. It doesn't matter whether they are in the A bar form or in A form, right? You can A bar එකක් විදිහට තිබ්බත් A එකක් විදිහට තිබ්බත් it's going to indicate one particular variable, A. Then මෙතන you got A bar, B and C bar. So there are 3 different letters. That means 3 different variables. ඔයාට A bar එකකුයි A එකකුයි තිබ්බොත් එතන variables දෙකක් නැහැ. Just one single variable. A bar කියන්නේත් Aම තමයි, A කියන්නේත් Aම තමයි. It's a one single variable. So here you got different kinds of variables, or like different types of variables, which is A bar, B and C bar. So 3 different letters are there. So 3 variables are there, right? So I'm going to write in the above expression. You don't need to write these things. You can ඔයගොල්ලෝ ගාන හදනකොට මේ අපි දැන් මේක ලියා ගන්නකොට ලියා ගන්න in the above expression, there are three different variables which are A, B, and C. Right? So we determine different number of variables. Very simple thing. So the second thing that you have to do is draw the input lines. Now, what is this input lines? For each and every variable. Right? Input line means nothing, it's just 3 lines, right? This will help you to draw your circuit in an easy manner, right? Make a technique එකක් පාවිච්චි කරලා, right? මෙහෙම්මම කරන්න කියලා නීතියක් නැහැ, but if you follow this, it will be easier for you to do things, right? Now, third step is the crucial one, right? So in third step, you are asked to complete the circuit, or like to draw the circuit. But when you are going to draw the circuit, there are several rules that you need to follow. Now, it is something like this. Now, if I ask you to solve this matter, if I ask you to do this, there are certain way that you are going to approach this, right? You are not just going to start it like 3 plus 5 is 8, 8 into 2 is 16, 16 divided by 2 is 8, 8 minus 5 is 3. No, you are not going to do that. Right? Oh, right? You are not going to do this blindly. So instead of that, you know there is a method of accessing this or like solving this. So which you may have learned as BODMAS, right? So brackets, right? Then multiplications, divisions are done by, then the what we call the addition and subtraction is going to be happen later, right? So there is an order. First you think about the brackets, then you think about the multiplication, division kinds of things, then you think about the additions and subtractions kind of things. So these things are called operators according to the mathematics. Now, when it comes to the Boolean algebra, inside our expression, now our expression was A bar plus B dot C bar. Now, in this expression, we have operators too. Bar is one operator, plus is another operator, right? Dot is another operator. And as well as the brackets, they should have a priority as well. So once we know the order to treat these operators, then it is a piece of cake of drawing this circuit. So you only need to remember what is the order of treating these operators, right? So what should be the order? The order should be brackets comes first, right? I'll write the sentence with this as well, so it will complete the thing. Follow the order as brackets, not, and O. for the operators in the expression to complete the circuit. Right. So what should be the order? Brackets should be treated first. Then if you got operators inside the bracket, so you should go into the bracket. Then should see what are the operators. So according to the operators, not is treated first, and is treated next, and the O is treated as last. Right? Oh, literally ලියාගන්න ඕනේ මම වෙලාව දෙන්නම් ලියාගන්න. Just see how I'm doing things. Right? So now what is our expression? It says F equals A bar plus B dot C bar. That is our expression. So earlier we were having these input lines. Right? So we are now just thinking about the expression. Now expression is here and we know the order now. Brackets happens first, not happens next, and happens later, and O happens as the last. So do we got brackets here? Yes, we do got brackets. That is in the B dot C bar term. So first we look at the B dot C bar term. So once we move into the brackets, there are two operators inside it. First one is the dot, the other one is the not. Now, who is having the priority from these two? It's the not operator. So that means we are going to create not, or like we are going to create C bar in the first place. So it's simple. Take a line from C, put that line inside a NOT gate. So it will give you a C bar. Simple as that. So we are done with C bar. We are still inside the brackets. We have a dot, that means the AND operator, in between letter B and the C bar. So we have C bar over here. We have created that. So we need B now. So we can take B. So if we are trying to cross a line, we just jumped over it. And now you can send these two lines through an AND gate. So this will receive B, and the output is going to receive B dot C bar. Simple as that. Right? And when you have B dot C bar, that means you are done with the bracket. Right? So you had a bar, you had a dot. So you deal with those. Now come out of the brackets. So you have two things again. What are the two things? You got a plus operator, that is O, and another bar, that is not. So from those two, who's going to have the priority? It's the not operator, because our order is brackets, not, and O. So first we create the A bar. So how to create the A bar? We take a line from A, jump it over B, jump it over C, and we just flow it through a NOT gate, which is going to give us A bar. Now we are done with A bar, and we have to deal with the plus. Plus means we need a O gate. O operation happens in between who? In between A bar and this big term, B dot C bar. So now we got B dot C bar over here, right? We got B dot C bar over here, and we got A bar over here. So now we only need to send this through an OR gate to take the output. What is going to be the output? A bar plus B dot C bar. That is going to be your final output. Got it, people? Is that clear? Right, great. So that is the way that you are going to finish this off, right? So people, if you can quickly write this down, we can end the session after that, right? So you can write this down and you can leave, right? There you go. I'll move the screen little by little, so people who are copying can be copied further. Yes, yes, I will zoom out a little bit. All right, okay, okay. There you go. So by next week, people, we will be able to learn how to draw the truth table for a given circuit. It is something very similar like this, but there are the order of the operators will be the same when we are like figuring out. So it's just a matter of drawing the truth table or like constructing the truth table. Right? We'll see it on next week. So once you're done with this, we can end the session.